Have you ever heard of a diamond harder than a diamond? It sounds like a riddle, but it's a real scientific quest that has baffled researchers for over half a century. This isn't just any gem. It's a super material that could change the world. So, what is this mysterious substance, and why has it been so incredibly hard to find? Let's travel back to 1967. Scientists were examining fragments of the Canyon Diablo meteorite, the very one that carved out the massive Barringer crater in Arizona 50,000 years ago. Tucked inside this cosmic traveler, they discovered tiny crystals. Under a microscope, they didn't look like the typical cubic structure of a normal diamond. Instead, their atoms were arranged in a hexagonal pattern. They named this new mineral Lonsdaleite, after the pioneering crystallographer Dame Kathleen Lonsdale. The theory was simple and electrifying. When a graphite-bearing meteorite smashes into Earth, the immense pressure and heat should transform the graphite as hexagonal carbon structure directly into a hexagonal diamond. This new diamond, Lonsdaleite, was predicted to be even harder than a regular diamond, up to 58% harder, in fact. Imagine that for a moment. A material that could potentially cut through anything, revolutionizing industries from mining to manufacturing. The discovery was hailed as a monumental breakthrough. But then, a problem emerged. A very big problem. Nobody could find it again. For decades, scientists scoured other meteorite samples and tried to replicate the impact conditions in their labs, but Lonsdaleite remained elusive. The initial samples were so minuscule and mixed with other minerals that they were incredibly difficult to study. Some scientists began to doubt its very existence. Was Lonsdaleite just a myth? A misinterpretation of flawed diamond structures? The scientific community was divided. The debate raged on for years. Was the 1967 discovery a fluke, or were we just missing a key piece of the puzzle? The controversy deepened as researchers pointed out that the hexagonal patterns seen in the meteorite could just be a type of structural defect in regular diamonds, not a unique mineral. The dream of a super-hard diamond seemed to be fading. It felt like we had discovered a treasure map, only to find the treasure was never really there. But a few dedicated teams refused to give up. They believed Lonsdaleite was real, and they were determined to prove it. The breakthrough finally came, not from a fiery meteorite impact, but from a carefully controlled lab environment. A team of scientists, including researchers from Australian National University and RMIT University, decided to try a different approach. Instead of trying to replicate the chaotic violence of a meteor strike, they focused on precision. They took a small chip of glassy carbon, a non-crystalline form of carbon, and subjected it to mind-boggling pressure using a diamond anvil cell. This device can create pressures equivalent to 640 African elephants balancing on the tip of a ballet shoe. But pressure alone wasn't the secret. The team realized that another force was crucial: shear stress. Think of it like a sliding or twisting force. As they applied immense pressure at high temperatures, they also applied this shear force, which helped the carbon atoms slide into the correct hexagonal formation. And then it happened. Under the watchful eyes of their advanced electron microscope, they saw it. For the first time, they had created pure, substantial hexagonal diamonds right there in the lab. They weren't just tiny, jumbled specks like in the meteorite. These were real, well-formed Lonsdaleite crystals, larger and purer than any ever seen before. The team was ecstatic. They had not only confirmed that Lonsdaleite is a real, distinct mineral, but they had also figured out the recipe to make it. The secret ingredient wasn't just heat and pressure. It was the addition of shear stress that guided the atoms into their super-strong hexagonal shape. This finally explained why it was so rare in nature. The specific conditions, intense pressure combined with just the right amount of sliding force, are incredibly difficult to achieve, even during a cataclysmic meteorite impact. So what does this mean for us? The successful synthesis of Lonsdaleite isn't just about settling a 50-year-old scientific debate. It opens the door to a whole new world of technology. Imagine ultra-hard coatings for drill bits that can tear through rock with unparalleled efficiency, making mining and resource exploration faster and cheaper. Picture surgical tools so sharp and durable they can make incisions with microscopic precision. Or think about protective coatings for electronics and machinery that are virtually scratch-proof. The applications are almost limitless. Because Lonsdaleite is made of carbon, one of the most abundant elements on Earth, it has the potential to be a widely used super material. If we can scale up production. The research team is now working on refining their method to create larger quantities of Lonsdaleite at lower pressures, which would make it commercially viable. The story of Lonsdaleite is a perfect example of the scientific process in action. It's a tale of a stunning discovery, followed by decades of doubt and controversy. And finally, a triumphant breakthrough driven by persistence and ingenuity. It started with a rock that fell from the sky and ended in a lab, with a discovery that could reshape our technology. The diamond harder than a diamond is no longer a myth. It's real, and its journey is just beginning. What was once a cosmic mystery is now a tangible key to our future. Thanks for watching. If you found this story as fascinating as I did, make sure to hit that like button and subscribe for more deep dives into the world of science and discovery. See you next time.